Asteroid Mining, The Gold Rush of the Future. Written and published by Ciro Irmici. Feel free to subscribe for more content. Now let's get into the book. Introduction. The New Frontier of Space Mining. The human story has always been one of exploration, of pushing beyond boundaries and venturing into the unknown in search of greater opportunities. From the discovery of new continents to the extraction of precious resources from deep within the Earth, our history is rich with tales of bold adventures and technological leaps that have shaped the course of civilization. Today we stand at the edge of another groundbreaking chapter, one that takes place far beyond the confines of our planet. The vast, uncharted frontier of space has become the next arena for exploration, and at the heart of this new journey lies one of the most tantalizing prospects: asteroid mining. Asteroids, those seemingly lifeless rocky bodies drifting through the void of space, are actually treasure troves of valuable resources. Locked within their rugged surfaces are vast quantities of rare metals, precious minerals, and even essential compounds like water, all of which have the potential to revolutionize industries on Earth and support human expansion into the solar system. Just as the gold rush of the 19th century transformed entire economies and regions, the gold rush of the future could be sparked by these celestial bodies orbiting in the asteroid belt. But asteroid mining is more than just a quest for wealth. It represents a pivotal step in our species' evolution, a move towards becoming an interplanetary civilization. The technology required to extract resources from asteroids pushes the boundaries of engineering, robotics, and space travel. The ethical and legal questions surrounding the ownership and exploitation of these resources challenge our existing frameworks and demand new international cooperation. And the environmental implications, both for Earth and for space, raise profound questions about sustainability and the responsible use of the cosmos. In this book, we will explore every facet of asteroid mining, from the visionary pioneers driving this field to the technological marvels that make it possible. We will dive deep into the economic impact, examining how the influx of space resources could disrupt and reshape industries on Earth. We will also consider the environmental and ethical questions that come with the extraction of materials from beyond our planet. As we look towards a future where humanity may one day mine asteroids on a routine basis, we are standing on the cusp of a new era, one that could redefine our relationship with the universe and create opportunities that were once confined to the realm of science fiction. Whether you are a curious space enthusiast, an investor in future technologies, or simply someone fascinated by the unknown, this book invites you to embark on a journey to the stars, where the gold rush of the future awaits. Chapter 1. The Birth of Space Mining, History and Vision. Humanity's fascination with space has deep roots in both imagination and ambition. From the earliest days of civilization, the stars have been a source of wonder, mystery, and speculation. Stories of voyages to the moon, alien civilizations, and distant planets have filled our cultural mythology, long before space travel became a scientific possibility. Yet, it wasn't until the 20th century that we began to transform these dreams into reality, with the first steps towards exploring space. Now, in the 21st century, we stand on the verge of another transformation, one where space is not just a destination for exploration, but a new frontier for industry. Asteroid mining is poised to be one of the most significant milestones in this journey. From science fiction to science fact, the concept of asteroid mining has been a part of science fiction for decades. Writers and visionaries like Arthur C. Clarke and Isaac Asimov imagined futures where humans extracted resources from distant asteroids to fuel space colonies and interstellar travel. These stories painted pictures of advanced civilizations, thriving on the wealth and materials harvested from the cosmos. While these ideas were often dismissed as fanciful, they planted the seeds of what would eventually become a serious area of scientific inquiry. By the late 20th century, space exploration had already seen significant milestones. The launch of Sputnik in 1957, human landings on the Moon during the Apollo missions, and the establishment of permanent space stations orbiting the Earth. As humanity began to explore space more seriously, a new realization dawned: space was not just a vast emptiness, it was filled with resources. The asteroids that populate our solar system were discovered to contain many of the same minerals and metals that we mine on Earth, and in far greater concentrations. Scientists began to propose that asteroid mining could not only support future space exploration but also address some of the growing resource challenges on Earth. As natural resources on our planet became more difficult and expensive to extract, the idea of tapping into the abundant materials in space started to gain traction. The turning point, from fiction to serious science. The transition from science fiction to serious science was gradual, but pivotal moments in space exploration helped push asteroid mining into the realm of possibility. One of the key drivers was the discovery that asteroids contain a wealth of metals, including platinum, nickel, and iron, as well as valuable resources like water, which can be split into hydrogen and oxygen for fuel. These findings transformed asteroids from being perceived as mere space rocks to valuable resource-rich bodies. The turning point came in the early 21st century when several private companies began to seriously explore the possibility of asteroid mining. Companies like Planetary Resources and Deep Space Industries were founded with the explicit goal of developing the technologies needed to mine asteroids. Although both companies have since evolved or shifted focus, their efforts brought asteroid mining into the spotlight and helped to catalyze the industry. Planetary Resources, founded in 2012, set out with the bold vision of identifying, mapping, and eventually mining near-Earth asteroids. Its founders and investors included high-profile figures from the tech industry, such as Google executives Larry Page and Eric Schmidt. The company's mission was to unlock the enormous value contained in space, starting with small near-Earth asteroids that could be accessed with relatively low energy costs. Though the company faced financial challenges, its work laid important groundwork for the industry. Around the same time, Deep Space Industries also emerged as a key player. Founded in 2013, its goal was to develop spacecraft capable of prospecting and eventually extracting materials from asteroids. The company promoted the idea of harvesting space to create a sustainable space economy, which would reduce the cost of space exploration by using resources found in space, rather than transporting everything from Earth. NASA's role in the asteroid mining vision. It wasn't just private companies that recognized the potential of asteroid mining. Government space agencies, particularly NASA, also played a critical role in advancing this field. NASA's missions, such as OSIRIS-RX and Japan's Hayabusa missions, aimed to study and collect samples from asteroids. These missions provided invaluable data about the composition and structure of asteroids, confirming that they contained many of the resources needed to support both life and industrial processes in space. NASA also began to explore the idea of using asteroid mining to support future human missions to Mars and beyond. By mining water from asteroids, for example, spacecraft could produce fuel in space, significantly reducing the cost and complexity of long-duration missions. This vision of in situ resource utilization, ISRU, became a cornerstone of NASA's plans for future space exploration, emphasizing the importance of using local resources to sustain human activities in space. The visionaries and pioneers. The dream of asteroid mining wouldn't have gained as much momentum without the contributions of visionaries who believed in the potential of this industry. Elon Musk, through his company SpaceX, has been instrumental in driving down the cost of space travel, making access to space more affordable. While SpaceX is not directly involved in asteroid mining, its advancements in reusable rocket technology are critical to the future of space-based industries, including mining. Meanwhile, Jeff Bezos, through his company Blue Origin, has spoken openly about his vision for a future where millions of people live and work in space. Bezos envisions a space-based economy where industries like mining take place off Earth, allowing humanity to preserve our planet while expanding into the solar system. These pioneers are not only pushing the boundaries of what is technically possible but are also reshaping how we think about the future of industry and civilization. Asteroid mining, once a distant fantasy, is now being discussed in boardrooms, research institutions, and government agencies as a serious opportunity for economic and technological growth. Looking forward. As we stand at the dawn of the asteroid mining age, it's clear that the journey has only just begun. The history of space mining is still being written, and the visionaries leading the charge are laying the groundwork for a future that could fundamentally reshape humanity's relationship with space. This chapter has introduced the birth of this bold new industry, highlighting the pioneers, companies, and missions that have brought us to this point. The next step: delving into the resources themselves. In the next chapter, we will explore what exactly lies within these asteroids and why they hold such immense value for the future of humanity. Chapter 2: What are we mining? Key resources in asteroids. When we think of asteroids, many of us envision barren, rocky bodies floating in the cold vacuum of space, seemingly devoid of anything valuable. But in reality, these ancient remnants of the solar system's formation are packed with resources that could be critical to both Earth's industries and humanity's expansion into space. From rare metals and precious elements to essential compounds like water, the riches contained within asteroids have sparked intense interest in space mining. In this chapter, we'll dive into the specific resources that make asteroids such an attractive target for future mining operations. 1. Rare metals, platinum, gold, and more. Perhaps the most tantalizing prize within asteroids is the abundance of rare and precious metals. Unlike Earth, where tectonic activity has concentrated many of these valuable elements deep within the planet's crust, asteroids contain rich, accessible deposits of metals like platinum, gold, nickel, and cobalt. These elements are crucial for a wide range of industries, from electronics manufacturing to renewable energy technologies. One of the most valuable metals found in abundance on asteroids is platinum. On Earth, platinum is rare and costly to extract, but it is essential in many applications such as catalytic converters in cars, fuel cells, and various electronics. The metal's scarcity on our planet has kept prices high, but the potential to access large quantities from asteroids could radically change the supply and demand dynamics of the platinum market. Some asteroids, particularly those classified as M-type, metallic, contain incredibly high concentrations of these metals. A single asteroid just a few hundred meters in diameter could contain more platinum than has ever been mined in the history of humanity. The financial implications are staggering. Asteroid mining could potentially introduce trillions of dollars worth of these materials into the global economy. Gold, another metal synonymous with wealth, is also found in certain types of asteroids, alongside other valuable elements like palladium and iridium. As industries continue to demand these metals for use in advanced technologies, asteroid mining offers the promise of practically limitless supplies. However, the influx of such vast amounts of rare metals could also disrupt traditional markets and create new economic paradigms. 2. Water and hydrogen, fuels for the future. Water, one of the most abundant compounds in the universe, is a critical resource not just for sustaining life, but also for enabling deeper space exploration. Asteroids, particularly carbonaceous chondrites, contain significant amounts of water in the form of hydrated minerals and ice. This discovery is perhaps even more exciting than finding precious metals, because water can be split into hydrogen and oxygen, essential components for rocket fuel. The ability to mine water from asteroids and convert it into fuel could revolutionize space travel. Instead of launching all fuel from Earth, which is costly and inefficient, future missions could refuel at way stations in space using locally sourced asteroid water. This concept, known as in situ resource utilization (ISRU), has the potential to drastically reduce the cost of space missions and open the door to long-term human settlement in space. Beyond fuel, water is also critical for life support systems. It can be used to produce oxygen for breathing and can support agricultural systems for growing food in space habitats. As humanity pushes further into the solar system, the ability to extract and use water from asteroids could be the key to sustaining human life on other planets or in deep space habitats. 3. Exotic materials, the building blocks of new technologies. In addition to rare metals and water, asteroids contain a variety of exotic materials that could play a crucial role in the development of new technologies. For example, carbon-rich asteroids may contain organic compounds that could serve as the raw materials for constructing lightweight, durable materials in space. These carbon-based compounds, such as fullerenes and other complex molecules, have unique properties that could lead to advances in nanotechnology, electronics, and materials science. One particularly intriguing possibility is the extraction of helium-3, a rare isotope that is thought to be abundant on the Moon and in certain asteroids. Helium-3 has been proposed as a potential fuel for nuclear fusion, which could provide a nearly limitless source of clean energy if fusion reactors can be perfected. While fusion technology is still in development, the prospect of mining helium-3 for future energy production could be a game-changer, offering a new energy frontier that would reduce our dependence on earthbound resources. Moreover, asteroids may also contain precious metals used in advanced electronics, such as tantalum and niobium. These materials are critical for producing high-performance capacitors and other electronic components, and they are increasingly in demand as industries expand into areas like 5G technology, electric vehicles, and renewable energy systems. The ability to source these elements from asteroids could help meet growing industrial demand while reducing the environmental impacts of mining on Earth. 4. The types of asteroids and their unique resources. Asteroids are generally classified into three main types based on their composition: C-type, carbonaceous; S-type, silicaceous; and M-type, metallic. Each type offers different resources, making it important to target specific asteroids for mining based on the desired materials. C-type asteroids. These are rich in carbon and water-bearing minerals. C-type asteroids are valuable for their water content, which can be processed into fuel. Additionally, they may contain organic molecules that are the building blocks of life and useful for creating advanced materials. S-type asteroids. These are composed primarily of silicate minerals and metals like iron, nickel, and magnesium. While not as water-rich as C-type asteroids, S-types contain significant amounts of metals, including valuable platinum group metals. M-type asteroids. These metallic asteroids are primarily made of nickel and iron, but they also contain precious metals like platinum, gold, and cobalt. These asteroids are considered some of the most valuable targets for mining due to their high metal content. Each asteroid type presents unique opportunities, and future space mining operations will likely focus on specific types based on the needs of the mission, whether for fuel, construction materials, or valuable metals. 5. Challenges of extracting resources from asteroids. While the resources contained in asteroids are vast, extracting them presents a host of challenges. Mining in space is not as simple as setting up a mine on Earth. It involves advanced robotics, automation, and innovative extraction techniques that are still in development. Low gravity, radiation exposure, and the vast distances between asteroids and Earth create additional hurdles. One of the key challenges is transporting mined materials back to Earth or other space destinations. Unlike mining operations on Earth, where materials are typically moved by truck or rail, space mining requires highly efficient and reliable spacecraft to transport the mined resources. In some cases, processing materials directly on the asteroid may be more practical, reducing the need to transport raw materials across vast distances. 6. The economic potential of asteroid resources. The economic potential of asteroid mining is staggering. Estimates suggest that a single asteroid could contain trillions of dollars worth of metals and other resources. For example, NASA has identified the asteroid 16 Psyche as a potential target for exploration. This metallic asteroid is thought to contain enough iron, nickel, and precious metals to be valued at around $10,000 quadrillion, an amount that dwarfs the entire global economy. While the full-scale commercialization of asteroid mining is still in the future, the potential rewards are driving significant investment in the field. Governments and private companies alike are looking towards the stars, eager to be among the first to tap into these celestial riches. The discovery and extraction of asteroid resources could transform the global economy, create entirely new industries, and offer solutions to some of the Earth's most pressing resource challenges. Asteroids are far more than just rocky remnants of the solar system's formation. They hold the key to a future where humanity's dependence on Earth's limited resources could be lessened, opening up new possibilities for technological advancement and space exploration. In the next chapter, we'll take a closer look at the cutting-edge technologies being developed to mine these distant bodies and bring their riches back to Earth. Chapter 3. The Technology of Tomorrow, Tools for Asteroid Mining. Asteroid mining represents one of the most technologically ambitious projects humanity has ever undertaken. Extracting valuable resources from a rocky, distant body in space requires engineering solutions unlike anything used on Earth. These technologies must be capable of operating in the harsh conditions of space, where extreme temperatures, microgravity, and cosmic radiation present significant challenges. However, the drive to overcome these obstacles is fueling incredible innovation, leading to new tools and techniques that may not only change how we access space resources but also revolutionize industries on Earth. In this chapter, we'll explore the cutting-edge technologies being developed to make asteroid mining a reality. From the spacecraft designed to travel millions of kilometers through the void, to the autonomous robots that will mine materials in space, these advancements are pushing the boundaries of what's possible. Spacecraft and propulsion systems. Reaching the asteroids. One of the first challenges in asteroid mining is simply getting to the target. Unlike Earthbound mining operations, space mining requires precision in navigating the vast distances of the solar system. While it's true that many asteroids pass close to Earth at certain points in their orbits, the journey to these bodies is still an immense logistical challenge. Spacecraft must not only travel to the asteroid but also carry all the necessary equipment for mining and transporting resources back. Traditional chemical rockets have long been the backbone of space travel, but they are expensive and require vast amounts of fuel, making them less practical for sustained mining missions. To meet the needs of asteroid mining, engineers are turning to more advanced propulsion technologies like ion drives and solar electric propulsion systems. These systems use electric power generated from solar panels to ionize and accelerate particles, creating a highly efficient form of thrust that can sustain long-duration missions with less fuel. Although these propulsion systems provide less thrust than traditional rockets, they are far more efficient for the slow, steady journeys required for asteroid mining. Solar sails offer another potential solution. By harnessing the pressure exerted by sunlight, these large, reflective sails allow spacecraft to travel through space without using fuel, making them an attractive option for missions that need to remain in space for long periods. Ultimately, the goal is to develop reusable spacecraft capable of making multiple trips between Earth and nearby asteroids, reducing the overall cost of mining operations and making space travel more sustainable. Autonomous mining robots, the workhorses of space. Once the spacecraft reaches its destination, the real work begins. Mining an asteroid is no simple task, especially given the lack of gravity and the extreme conditions on these space rocks. Earth-based mining relies on heavy machinery to break through rock and extract valuable minerals, but these machines aren't practical in space, where weight and transport costs must be minimized. To overcome these challenges, space mining companies and researchers are developing advanced autonomous robots that can perform mining tasks with minimal human intervention. These robots, designed to withstand the harsh environment of space, will be equipped with sensors, cameras, and AI-driven algorithms that allow them to analyze their surroundings, make decisions, and perform tasks independently. Some of the most promising technologies include robotic arms and drills that can break through asteroid surfaces and retrieve valuable materials. These robots will be designed to operate in low-gravity environments, where the lack of a strong gravitational pull presents unique challenges. For example, traditional Earth-based drills rely on gravity to stabilize themselves during operations, but in space, alternative methods such as anchoring mechanisms or controlled thrust will be necessary. The robots may also need to process the materials directly on the asteroid. Instead of transporting raw asteroid rock back to Earth, mining systems could extract the valuable metals or water and leave behind the waste materials. This approach minimizes transportation costs and allows more efficient use of the spacecraft's capacity. In-situ processing technologies, which extract and refine resources directly on-site, could play a crucial role in making asteroid mining economically viable. 3D printing and manufacturing in space. Building from asteroids. One of the most exciting developments in space technology is the growing ability to manufacture objects directly in space using 3D printing. This capability has enormous potential for asteroid mining, as it could allow mining operations to create tools, replacement parts, or even entire structures using materials harvested from the asteroid itself. For example, metals like nickel and iron, abundant in many asteroids, could be used to produce parts for mining equipment or space infrastructure. The concept of building in space, rather than launching everything from Earth, dramatically reduces the cost and complexity of space missions. Rather than carrying all necessary equipment from the start, future space missions might bring just a 3D printer and raw materials, allowing them to manufacture whatever they need as they go. This space-to-space manufacturing paradigm could also extend beyond asteroid mining, helping build space stations, habitats, or even spacecraft directly from resources harvested in space. The ability to create infrastructure on demand from local resources is one of the key technologies that could enable long-term human settlement in space. NASA and other space agencies have already begun experimenting with 3D printing technologies in space. The International Space Station has tested 3D printers that use plastic, metal, and even regolith, moon dust, as raw materials. These early experiments pave the way for more advanced uses of 3D printing in future asteroid mining operations. Transporting resources, bringing space gold back to Earth. Once the resources have been extracted and processed, the next challenge is transporting them back to Earth or other space destinations. This presents a unique logistical hurdle. Given the high costs of space travel, simply shipping raw materials back to Earth may not always be practical. In many cases, it might be more efficient to use the materials in space, particularly for constructing space stations, refueling depots, or even space colonies. However, for valuable metals like platinum, gold, or rare earth elements, bringing them back to Earth could be immensely profitable. This is where spacecraft with reusable designs will play a key role. Reusable landers or cargo ships could shuttle between asteroids and Earth, minimizing the need to build entirely new craft for each mission. One innovative solution being explored is the use of small robotic space tugs that could attach to mine materials and ferry them back to Earth. These tugs would rely on efficient propulsion systems to navigate the vast distances, potentially powered by solar energy or other advanced propulsion methods. Once near Earth, these materials could be captured by spacecraft designed to safely land them for retrieval. Another potential development is the creation of orbital processing stations, where raw materials are refined or converted into more usable products in space before being sent back to Earth. This would reduce the volume of materials needing to be transported and optimize the economics of space mining missions. Addressing the challenges of space mining. While the technologies we've discussed hold incredible promise, asteroid mining is not without its challenges. The development of reliable, autonomous systems that can operate millions of kilometers from Earth is a daunting task. Communication delays, the harsh environment of space, and the unpredictable nature of asteroids themselves all add layers of complexity. However, with each new advancement, humanity is getting closer to overcoming these obstacles. NASA's OSIRIS-Rx mission, which successfully collected samples from the asteroid Bennu, is a prime example of how far space technology has come. The mission demonstrated the feasibility of not only reaching and exploring asteroids but also bringing materials back to Earth. As the private space industry continues to grow, more players are entering the race to develop viable asteroid mining technologies. Companies like SpaceX, Blue Origin, and smaller startups are working on everything from propulsion systems to robotic mining equipment, bringing us ever closer to the day when space mining becomes a reality. The future of space mining technology. The future of space mining technology is bright and rapidly evolving. Each breakthrough brings humanity one step closer to tapping into the incredible wealth of resources waiting in the asteroid belt and beyond. The same technologies being developed for mining could also have far-reaching impacts on industries on Earth, from automated mining operations to new manufacturing techniques that reduce the need for environmentally damaging resource extraction. In the coming decades, we may see the launch of the first fully operational asteroid mining missions, supported by reusable spacecraft, autonomous robots, and in-space manufacturing capabilities. These missions will pave the way for a new era in which humanity no longer views space as an unreachable frontier but as an integral part of our industrial and economic landscape. Chapter 4: Economic Impact, Asteroid mining and global markets. Asteroid mining is not just a leap in space exploration. It represents a potential shift in the global economy that could have profound effects on industries, markets, and even nations. The allure of mining precious metals and resources from asteroids is clear. It promises a nearly limitless supply of materials that are rare and increasingly difficult to extract on Earth. However, the ripple effects of this new frontier extend far beyond simply accessing these resources. If asteroid mining becomes a reality, it could fundamentally change the way we think about scarcity, value, and economic growth. In this chapter, we explore the economic potential of asteroid mining, the industries it could disrupt or transform, and the broader implications for global markets and trade. While still in its early stages, asteroid mining is already attracting the attention of investors, governments, and corporations, all vying to take part in what could become the next major economic boom. The trillion-dollar opportunity. Asteroids are not just space rocks, they are potential gold mines floating through the solar system. Some contain enormous quantities of metals like platinum, gold, nickel, and cobalt, while others hold water and other vital compounds that could be used to fuel space missions or support human life in space. The scale of these resources is staggering. A single medium-sized asteroid could contain more platinum group metals than have ever been mined on Earth, and NASA estimates that certain asteroids could be worth trillions of dollars. If asteroid mining reaches commercial viability, the influx of these materials could dramatically increase the global supply of rare metals. This would not only lower the cost of key industrial materials but also make it easier for emerging technologies to access the resources they need. Platinum, for example, is critical for fuel cells and other clean energy technologies, while nickel and cobalt are essential for batteries and electronic devices. With asteroid mining, the bottleneck on the supply of these materials could be significantly reduced, enabling faster growth in sectors like renewable energy, electric vehicles, and advanced manufacturing. However, this dramatic increase in supply could also create instability in certain markets. Prices for precious metals may drop as more resources flood the market, which could have both positive and negative effects. For industries that rely on these materials, lower costs could spur innovation and reduce production costs, while traditional mining industries on Earth might struggle to compete with the abundance of materials from space. The disruption of Earth-based mining. Asteroid mining has the potential to significantly disrupt traditional mining industries on Earth. Currently, mining companies must invest heavily in locating, extracting, and refining precious metals and minerals from increasingly depleted and difficult-to-reach deposits. These operations are not only costly but also often environmentally damaging, causing deforestation, water pollution, and significant carbon emissions. In contrast, space mining offers the possibility of extracting resources without the same environmental impact. Once the technology is fully developed, mining asteroids could be more efficient and sustainable than terrestrial mining. This shift could lead to a decline in demand for Earth-based mining operations, particularly for metals like platinum, gold, and nickel, which are found in high concentrations on asteroids. Moreover, the global mining industry, which employs millions of people, may face significant challenges as space mining matures. While it is unlikely that asteroid mining will completely replace Earth-based mining in the near future, the long-term effects could reshape entire industries. Mining companies that fail to adapt may find themselves unable to compete with space-based operations, leading to consolidation in the sector and the emergence of new players focused on space mining technology. New industries and investment opportunities. The rise of asteroid mining will also create entirely new industries and investment opportunities. Companies that develop the technology to extract resources from space will be at the forefront of this new economic wave. These companies, which may include aerospace firms, robotics developers, and advanced materials manufacturers, stand to benefit immensely from the growth of space mining. Private investment in space exploration has already begun to ramp up, with major players like SpaceX and Blue Origin leading the charge. However, smaller startups focused specifically on asteroid mining are also attracting significant attention. Investors are betting on the potential of these companies to unlock the vast wealth of space resources, positioning themselves for long-term gains as the industry grows. In addition to mining and technology companies, other sectors could benefit from asteroid mining. The transport and logistics of moving materials from space to Earth will require sophisticated systems, creating opportunities for aerospace engineering and space transport firms. Additionally, industries focused on refining and utilizing these materials, such as clean energy, electronics, and construction, could see significant boosts in growth as space-sourced materials become more readily available. Governments are also likely to play a key role in shaping the economic landscape of asteroid mining. Countries that invest in space infrastructure and foster private sector involvement in space exploration may find themselves leading this new industrial revolution. Nations with strong space programs like the United States, China, and Russia are already positioning themselves to take advantage of the opportunities asteroid mining presents. International partnerships and agreements will likely emerge as countries collaborate to share knowledge, resources, and technology. Shifting global power dynamics. The introduction of asteroid mining could alter the balance of power in global markets, especially for countries heavily reliant on mining industries. Nations rich in natural resources currently hold significant economic and political leverage, but the widespread availability of asteroid resources could diminish this advantage. Countries without large mineral reserves on Earth, but with the technological capacity to participate in space mining, could become new economic powerhouses. This shift may create tensions between nations, especially as competition for space resources heats up. The lack of clear international regulations governing asteroid mining could lead to conflicts over who has the right to claim and exploit resources. As we saw with the early days of terrestrial exploration and colonization, the race for space resources could create new geopolitical dynamics that will need to be carefully managed to avoid conflict. At the same time, asteroid mining could foster greater international cooperation. The development of space infrastructure and mining technology requires vast resources and expertise, which may encourage countries to work together on joint ventures. Collaborative efforts, like those already seen with the International Space Station, could become the norm as nations pool their resources to unlock the potential of asteroid mining. A new space economy. In the long term, asteroid mining is likely to be a major driver of what some experts are calling the space economy. This new economic model envisions a future where industries are no longer confined to Earth, but extend throughout the solar system. Mining asteroids for precious metals, manufacturing products in space using locally sourced materials, and establishing colonies that rely on space-based resources could fundamentally change how economies function. Space tourism, asteroid mining, and even space-based manufacturing are all part of this vision, and they could become interconnected industries, fueling one another's growth. For instance, the development of asteroid mining technologies could also reduce the cost of building infrastructure in space, making it more affordable to establish space hotels or permanent human settlements on the Moon or Mars. By tapping into the resources of space, humanity may be able to move beyond the limitations of Earth's finite resources. In this sense, asteroid mining is not just an economic opportunity, but a pathway to creating a sustainable long-term presence in space. This space economy could support human life beyond Earth, providing the materials needed for space habitats, transportation, and even agriculture. Conclusion: the dawn of a new economic era. Asteroid mining promises to reshape global markets in ways we are only beginning to understand. The ability to access the vast wealth of resources in space could spark the next great economic revolution, one that extends far beyond the limits of our planet. From disrupting traditional mining industries to creating entirely new sectors and shifting global power dynamics, the economic impact of asteroid mining will be profound. While many of the necessary technologies are still in development, the momentum behind asteroid mining is undeniable. Investors, corporations, and governments are preparing for the dawn of a new era, one where space is not just a destination for exploration, but the foundation of a thriving economy. In the next chapter, we'll explore the environmental implications of asteroid mining, considering both the benefits and potential risks of extracting resources from space. How can this new industry contribute to sustainability, and what challenges must we address to ensure the responsible use of space resources? Let's take a closer look at the environmental impact of mining beyond Earth. Chapter 5. The Environmental Impact, Space Mining and Sustainability. The Earth is facing a growing crisis of resource depletion. As the global population expands and industries continue to demand more raw materials, we are rapidly exhausting the planet's natural reserves. Mining, deforestation, and industrial pollution have taken a toll on ecosystems around the world, leading to deforestation, biodiversity loss, and climate change. In this context, asteroid mining presents itself not just as an economic opportunity but as a potential solution to some of the environmental challenges we face. The idea of shifting resource extraction away from Earth and into space could alleviate pressure on our planet's ecosystems. But just as with any new technology or industrial frontier, asteroid mining also comes with its own environmental risks and ethical considerations. Will mining in space truly reduce the damage done to Earth? Or will it create new environmental concerns, both here and beyond our atmosphere? In this chapter, we explore these questions by examining the potential benefits and challenges asteroid mining presents for sustainability and the future of our planet. Easing the pressure on Earth's ecosystems. One of the most immediate environmental benefits of asteroid mining lies in its potential to reduce the need for resource extraction on Earth. Traditional mining practices, particularly for metals like platinum, gold, and nickel, are some of the most environmentally destructive activities humans undertake. Large-scale mining operations often involve the removal of vast amounts of soil, the destruction of natural habitats, and the use of toxic chemicals like mercury and cyanide to extract valuable metals from ores. These activities not only disrupt ecosystems but also lead to soil erosion, water pollution, and air contamination. Asteroid mining offers the possibility of obtaining these same materials without the need to dig up Earth's fragile ecosystems. If we can access the rich reserves of metals in asteroids, it could significantly reduce the demand for terrestrial mining. This, in turn, could help preserve forests, wetlands, and other critical habitats that are often cleared to make way for mining operations. Moreover, mining asteroids for water, a critical resource in space exploration, could have far-reaching environmental benefits for Earth. Freshwater resources on our planet are finite and increasingly under strain due to agriculture, industry, and climate change. By extracting water from asteroids and using it for space missions or converting it into rocket fuel, we can avoid depleting Earth's limited supply of fresh water for space exploration purposes. This shift would represent a small but significant step toward easing the burden on our planet's water systems. Sustainability in space. While the environmental benefits of reducing Earth-based mining are clear, asteroid mining presents new challenges in terms of sustainability. The process of extracting resources from space requires a considerable amount of energy and advanced technology, which brings its own environmental footprint. The energy needed to launch spacecraft, build mining equipment, and transport materials from space back to Earth could generate significant carbon emissions, particularly in the early stages of the industry when sustainable energy solutions may not yet be fully integrated. However, the very nature of asteroid mining opens the door to more sustainable practices in the long term. Space mining could be powered by solar energy, which is abundant in space. Without the interference of Earth's atmosphere, solar panels in space can capture sunlight much more efficiently than those on the ground. This makes solar power an ideal energy source for operating spacecraft, mining robots, and even processing stations in orbit. By relying on solar energy rather than fossil fuels, asteroid mining could become a largely self-sustaining operation with minimal environmental impact on Earth. Additionally, space offers the possibility of in-situ resource utilization, or using materials found in space to support operations. This means that instead of constantly launching equipment and fuel from Earth, space missions could harvest resources like water, metals, and even oxygen from asteroids to sustain themselves. For example, water from asteroids can be split into hydrogen and oxygen to create rocket fuel, allowing spacecraft to refuel in space without relying on Earth-based resources. This capability could significantly reduce the carbon footprint of space missions and contribute to the long-term sustainability of space exploration. Space debris and the ethical responsibility of space mining. While asteroid mining may help reduce environmental degradation on Earth, it introduces a new set of environmental concerns, specifically the issue of space debris. Space is already littered with thousands of defunct satellites, rocket parts, and fragments from collisions. This growing cloud of space junk poses a serious threat to both manned and unmanned space missions. As we look to expand our activities into asteroid mining, there is a risk that improper mining practices could add to the problem. If mining operations break off large chunks of asteroids or leave behind debris, this material could pose a collision risk for other spacecraft or even Earth. It is essential that the companies and organizations involved in asteroid mining develop responsible practices to minimize space debris and manage the remnants of mining operations. One solution could be to ensure that any waste material is left on the asteroid itself or safely directed away from heavily trafficked areas of space. Technologies designed to capture and process debris, as well as international regulations governing space mining practices, will play a crucial role in mitigating this risk. Moreover, the ethical implications of extracting resources from space must be considered. Asteroids are natural objects that have existed for billions of years, and while they may seem like inert rocks, they are part of the broader cosmic ecosystem. As humans begin to exploit these resources, questions arise about the ethical boundaries of space mining. Who has the right to claim and extract resources from an asteroid? How do we ensure that mining operations do not disrupt the orbits or structures of these bodies in ways that could have unforeseen consequences for other planets, moons, or space missions? These are complex issues that require careful consideration and international cooperation. The potential for environmental regeneration. One of the most hopeful aspects of asteroid mining is its potential to support environmental regeneration on Earth. By reducing the need for destructive mining practices, asteroid mining could allow for the restoration of ecosystems that have been damaged by resource extraction. Forests that were once cleared for mining operations could be allowed to regrow, and rivers that were polluted by mining runoff could recover over time. In addition, the availability of resources from space could enable the development of new, more sustainable technologies. For example, asteroid-derived metals could be used to create more efficient solar panels, batteries, or other renewable energy technologies. The abundance of certain rare elements in asteroids could also lead to breakthroughs in green technology, making it easier to transition away from fossil fuels and towards a more sustainable energy system. In the longer term, asteroid mining could even contribute to the establishment of self-sustaining space colonies, reducing humanity's dependence on Earth's resources and helping to preserve our planet's ecosystems. As we begin to think about life beyond Earth, the lessons learned from asteroid mining could guide us toward more sustainable practices in space and on our home planet. Conclusion: a balanced approach to space and Earth's environment. Asteroid mining holds the promise of reducing humanity's impact on Earth while opening up new frontiers of exploration and industry in space. However, achieving this vision requires a careful balance between technological advancement, environmental responsibility, and ethical stewardship. While the potential benefits of asteroid mining are significant, particularly in terms of reducing terrestrial resource extraction and developing sustainable energy solutions, it is crucial that we move forward with caution. As with any new industry, space mining must be developed with a commitment to minimizing its environmental footprint, both on Earth and in space. By harnessing the power of solar energy, developing sustainable mining practices, and addressing the ethical challenges of space exploration, we can ensure that asteroid mining contributes to a more sustainable future for humanity, both on our home planet and beyond. Chapter 6: Legal and Ethical Challenges of Asteroid Mining. Asteroid mining may open up a new frontier of resource extraction, but it also introduces a host of legal and ethical questions that humanity has barely begun to address. In many ways, the legal framework surrounding space resembles the early days of terrestrial exploration and colonization, where there was little regulation and the rules were shaped by whoever had the power to claim new lands. Space, however, presents a more complicated scenario. Unlike uncharted territories on Earth, space is considered a global commons, belonging to all of humanity, yet owned by no single nation or entity. As we look to the stars with plans to mine asteroids, one of the key questions is, who has the right to exploit space resources? The absence of clear, enforceable laws governing the ownership and use of these resources has led to significant uncertainty. On one hand, asteroid mining holds the promise of vast economic potential. On the other, it risks creating new conflicts, both among nations and between public and private actors. This chapter explores the current legal landscape, the ethical considerations of exploiting space resources, and the urgent need for international cooperation in establishing a fair and sustainable framework for asteroid mining. The Outer Space Treaty and its limitations. The foundation of international space law is the Outer Space Treaty, signed in 1967 by major spacefaring nations. This treaty laid out some of the basic principles that govern activities in space. Among its key provisions is the idea that space, including the moon and other celestial bodies, is the province of all mankind. It asserts that no nation can claim sovereignty over any part of space, and that the exploration and use of outer space must benefit all countries, not just those that can afford to go there. While the Outer Space Treaty was a landmark agreement at the time, it was established long before asteroid mining became a serious possibility. The treaty doesn't address specific issues around the commercial exploitation of resources in space. It also leaves many questions unanswered regarding how private companies can legally operate in space. For example, while the treaty prohibits national appropriation of celestial bodies, it is unclear whether extracting resources from an asteroid constitutes ownership. This ambiguity has led to different interpretations of the treaty's provisions and has created a gray area where private companies can stake their claims with little international oversight. In recent years, countries like the United States and Luxembourg have passed national legislation that supports private companies' rights to own and sell space resources. The U.S. Commercial Space Launch Competitiveness Act of 2015, for instance, explicitly allows American companies to extract and profit from resources mined in space, as long as they don't claim ownership over the celestial bodies themselves. This kind of legislation aims to encourage innovation and investment in the space mining industry, but it also raises concerns about the potential for unilateral actions that could undermine international cooperation. Who owns space? The debate over property rights. At the heart of the legal debate around asteroid mining is the question of property rights. If no one can claim ownership of space or celestial bodies, as the Outer Space Treaty suggests, how can companies or countries justify mining asteroids and selling the resources they extract? Some argue that mining resources is akin to fishing in international waters. While no one owns the oceans, those who catch fish in international waters can legally sell them. By this logic, asteroid resources should be considered free for anyone to extract, as long as the activities don't infringe on the rights of others. However, others believe that this approach could lead to a space rush, similar to the territorial grabs of past centuries, where the most powerful actors would seize the most valuable resources, leaving little for others. This fear has prompted calls for more robust international regulations to ensure that space remains a shared resource and that the benefits of space mining are distributed equitably. Without clear global rules, there is a real risk that asteroid mining could become a source of conflict, as countries and corporations vie for control over these valuable resources. The Moon Agreement, an additional treaty adopted in 1979, attempted to address some of these concerns by proposing that space resources should be managed as a common heritage of mankind and that any profits from their exploitation should be shared internationally. However, this agreement has been ratified by very few nations, and none of the major spacefaring countries, including the US, Russia, or China, have signed it. As a result, the Moon Agreement lacks the global consensus needed to serve as a basis for space mining governance. Ethical considerations. Exploiting space for profit. The ethical implications of asteroid mining go beyond legal concerns. While the economic benefits of mining asteroids are potentially enormous, the prospect of profiting from the exploitation of space resources raises deeper philosophical questions. Should space, a vast and untamed frontier, be treated like any other resource to be exploited for profit? Or does it hold a special status that requires a more thoughtful, responsible approach? One of the primary ethical concerns is that asteroid mining could reinforce existing global inequalities. The companies in countries that have the technological capabilities to mine asteroids are already among the world's wealthiest and most powerful. If asteroid mining becomes the next great economic boom, it could further concentrate wealth and power in the hands of a few, leaving developing nations at a disadvantage. This dynamic mirrors the historical exploitation of natural resources on Earth, where colonial powers profited at the expense of less powerful nations. To address these concerns, some experts have proposed the establishment of an international body, similar to the United Nations, that would oversee space resource extraction and ensure that the benefits are shared more equitably. This organization could set limits on how much any one entity can extract, create guidelines for environmental responsibility, and establish mechanisms for redistributing profits from space mining to support global development. While this idea may seem ambitious, it reflects the growing recognition that space exploration and resource extraction are not just technological challenges, but also ethical and moral ones. Environmental responsibility in space. Another ethical dimension of asteroid mining is its potential impact on the space environment. As discussed in the previous chapter, space debris is already a growing problem, and the introduction of mining operations could exacerbate this issue if not properly managed. While space may seem vast and empty, it is increasingly becoming a busy highway of satellites, spacecraft, and other equipment, all of which could be at risk from debris created by mining activities. Beyond debris, there are questions about the long-term effects of altering asteroids or other celestial bodies. While asteroids may appear inert and lifeless, they are part of the broader solar system, and their orbits and compositions could play roles that we don't fully understand. Mining asteroids, particularly on a large scale, could potentially disrupt their orbits or structures in ways that have unintended consequences. For example, could altering an asteroid's trajectory inadvertently create a collision risk for Earth or other planets? While these scenarios may seem far-fetched, they highlight the need for caution and foresight in any large-scale space mining operation. The need for international cooperation. As asteroid mining moves closer to reality, it is clear that no single country or company can go it alone. The challenges of developing a legal and ethical framework for space mining require broad international cooperation. Without clear rules and guidelines, the rush to exploit space resources could lead to conflict, environmental damage, and growing inequality. International cooperation will be key to ensuring that space remains a peaceful and shared domain, where the benefits of resource extraction are distributed fairly. This may require new treaties, agreements, or regulatory bodies that go beyond the current framework provided by the Outer Space Treaty. The development of such structures will not be easy, but they are essential if we are to navigate the complex legal and ethical challenges of space mining responsibly. Conclusion: shaping the future of space resource management. Asteroid mining represents a new frontier for humanity, one that offers immense potential but also raises profound legal and ethical questions. The current legal framework, built on the principles of the Outer Space Treaty, is not yet equipped to handle the complexities of commercial space resource extraction. Meanwhile, the ethical issues surrounding ownership, profit, and environmental responsibility in space require careful consideration. As we stand on the cusp of this new era, the choices we make now will shape the future of space exploration and the distribution of its benefits. Whether through new laws, international agreements, or ethical guidelines, humanity must ensure that asteroid mining is pursued in a way that respects the shared nature of space and promotes fairness, sustainability, and cooperation. Chapter 7: The Key Players, Nations, Corporations, and Pioneers. As the prospect of asteroid mining shifts from science fiction to impending reality, various nations, corporations, and individuals have positioned themselves at the forefront of this new industry. The race to extract resources from space is being driven by a blend of public ambition, private enterprise, and visionary leaders who believe the future of humanity lies among the stars. This chapter explores who the key players are in this bold new frontier, the roles they are playing, and how their efforts are shaping the landscape of space mining. Nations leading the way. Space has long been a realm where only governments could afford to operate. Early space exploration, from the moon landings to the establishment of the International Space Station, was driven by national space agencies, with funding and oversight provided by governments. This legacy continues, and even today, some of the most significant advancements in space exploration and asteroid mining are coming from government space agencies. The United States, through NASA, has been a pioneer in exploring asteroids. NASA's OSIRIS-Rx mission, which successfully reached the asteroid Bennu and returned a sample to Earth, represents one of the most significant achievements in asteroid exploration to date. This mission was not only a technical marvel but also a critical step in proving that humans can reach, study, and extract material from asteroids. NASA's leadership in space exploration remains central to the development of asteroid mining, and its missions serve as benchmarks for the industry. Other nations are also making strides. China, which has made significant investments in its space program, is looking beyond Earth's orbit. China's space agency, CNSA, has focused on lunar exploration but has ambitions to explore asteroids and expand its influence in space mining. Japan's Hayabusa missions have already returned samples from asteroids, showcasing the country's technological capabilities and determination to be a player in the space economy. These government initiatives are critical not only for technological advancements but also for establishing international norms and cooperation. However, the rise of private enterprise in space is starting to shift the balance, with corporations now driving much of the innovation and investment in space mining. Private corporations and the commercialization of space. In recent years, private companies have taken center stage in the space mining race. Corporations that once focused on launching satellites or delivering cargo to the International Space Station are now looking to the wealth of resources that lie in asteroids. What was once the exclusive domain of government agencies is rapidly becoming an industry where private enterprise sees the potential for enormous profit. One of the first and most notable companies to stake a claim in asteroid mining was Planetary Resources. Founded in 2012 with high-profile investors like Google's Larry Page and Eric Schmidt, Planetary Resources sought to become the first company to mine asteroids for precious metals and water. While the company has since struggled with funding and operational challenges, it played a significant role in igniting interest in asteroid mining and proving that private companies could take on ambitious space projects. Another key player is Deep Space Industries, founded with the goal of developing technologies to harvest resources from space. Unlike Planetary Resources, which focused more on precious metals, Deep Space Industries emphasized the extraction of water from asteroids as a means of supporting space exploration and in-situ resource utilization. The company envisioned a future where water from asteroids could be converted into fuel for spacecraft, making deep space missions more feasible. These companies, while early movers, faced significant financial and technological hurdles. Yet their efforts paved the way for a new wave of space companies, many of which are now supported by major aerospace firms like SpaceX and Blue Origin. SpaceX, founded by Elon Musk, has revolutionized space travel with its reusable rocket technology, drastically reducing the cost of launching payloads into space. Though SpaceX's primary focus is not asteroid mining, the company's advancements in space transport are critical to making mining operations possible in the future. Blue Origin, founded by Amazon's Jeff Bezos, is another company with its sights set on space infrastructure. Bezos has often spoken of a future where millions of people live and work in space, supported by a thriving space economy that includes asteroid mining. Blue Origin's development of rockets and space habitats is part of a larger vision to build a sustainable presence in space, one that will likely include mining resources from asteroids to support space colonies. These corporations represent the vanguard of private space exploration. Their work is not only driving technological innovation but also pushing governments to rethink their role in space. As private companies demonstrate their ability to operate in space, the traditional lines between government space agencies and private enterprise are blurring, creating a new hybrid model of space exploration. Visionaries and pioneers, the dreamers behind the technology. While governments and corporations provide the funding and infrastructure, it is often individual visionaries who propel industries forward. Asteroid mining is no different, and several key figures have emerged as pioneers in this field, driven by a combination of profit and a deep-seated belief in the future of humanity in space. Elon Musk is perhaps the most well-known figure in the space industry today. His ambitious vision of making humans a multi-planetary species, starting with the colonization of Mars, has inspired a new generation of space entrepreneurs and engineers. While SpaceX is primarily focused on transport, Musk's larger goals, such as using Mars as a stepping stone to further space exploration, are closely aligned with the potential of asteroid mining. Musk has spoken of using resources from space, particularly water, to enable long-duration missions to Mars and beyond. Jeff Bezos, through Blue Origin, shares a similar vision but with a different focus. Bezos envisions a future where Earth is primarily a place for living and light industry, while heavy industry and resource extraction take place in space. For Bezos, asteroid mining is a key component of this vision, providing the raw materials needed to build massive space habitats and infrastructure. His long-term view of space as a place of human expansion aligns closely with the goals of the asteroid mining industry. Beyond these high-profile figures, there are also lesser-known pioneers who have been instrumental in advancing asteroid mining. Individuals like Chris Lewicki, former president of Planetary Resources, and Daniel Faber, who led Deep Space Industries, have made significant contributions to the field, pushing the boundaries of what's possible and laying the groundwork for future efforts. Their work, while often overshadowed by the larger-than-life figures of Musk and Bezos, is crucial to the development of asteroid mining technology. These visionaries are united by a belief that humanity's future lies in space and that asteroid mining is one of the key steps in building that future. They see the immense potential in space resources, not just for economic gain but for securing a sustainable future for humanity. In their view, mining asteroids is not just about extracting metals. It's about creating the infrastructure that will allow humans to live and thrive in space. The role of international collaboration. While private companies and national space agencies are leading the charge, asteroid mining will likely require significant international collaboration. Space is not bound by the borders of Earth, and the legal, environmental, and ethical challenges of mining resources from asteroids are global in nature. Countries and companies will need to work together to establish frameworks for resource extraction that are fair, sustainable, and beneficial to all. Efforts like the Artemis Accords, a series of bilateral agreements between the U.S. and other countries, aim to establish norms for space exploration, including resource extraction. These agreements represent a step toward creating a legal framework for space mining, but they are only the beginning. As more nations and companies become involved in asteroid mining, the need for comprehensive international agreements will become increasingly important. Conclusion: the pioneers of tomorrow's economy. The race to mine asteroids is being driven by a diverse group of actors, from national governments and private corporations to visionary individuals who believe in the transformative potential of space. These key players are laying the foundations for an industry that could fundamentally reshape the global economy and humanity's relationship with space. As the technology continues to develop, the roles of these pioneers will evolve. Some will push the boundaries of innovation, creating new ways to explore and extract resources from space. Others will work to establish the legal and ethical frameworks needed to ensure that asteroid mining is conducted responsibly. Together, they represent the future of space exploration and the dawn of a new era in human industry. Chapter 8: The Future of Space Colonization and Asteroid Mining. The concept of humanity living among the stars has been a cornerstone of science fiction for generations, inspiring dreams of distant colonies on planets, moons, and space stations. As technology advances, those dreams are gradually edging closer to reality. But there's a critical piece missing from the picture of human life beyond Earth: resources. Establishing a permanent presence in space, whether on the Moon, Mars, or in orbit, requires vast amounts of materials, energy, and infrastructure. This is where asteroid mining comes into play. Asteroids, often considered little more than space debris, could hold the key to unlocking a sustainable future in space. These celestial bodies, scattered throughout the solar system, contain the essential raw materials needed to build space habitats, fuel spacecraft and support human life. In this chapter we'll explore how asteroid mining could become the backbone of space colonization, and why mining resources from these distant rocks could make long-term human settlement beyond Earth possible. The challenge of space colonization. At first glance, the idea of living in space might seem as simple as building a structure and sending supplies from Earth. However, the reality is far more complex. Establishing a human colony in space involves not only solving technological challenges but also addressing the fundamental problem of sustaining life far from our planet's abundant resources. The Moon, Mars, and space stations have all been considered as potential locations for colonies, but each presents a unique set of challenges. The Moon is relatively close to Earth, making it a prime candidate for early colonies. Yet it lacks the atmosphere and water resources needed to support life long-term. Mars, though more distant, offers a more Earth-like environment, with polar ice caps and a thin atmosphere, but the challenges of traveling to and from the Red Planet make it difficult to imagine constant supply runs from Earth. The cost and logistics of sending enough materials from Earth to build and maintain a colony are staggering. Rockets are expensive, and each launch only carries a limited payload. The prospect of supporting an entire settlement, especially a growing one, would require frequent resupply missions which would quickly become unsustainable. This is where asteroid mining can offer a solution, by providing the resources needed directly from space, reducing the need to constantly rely on Earth. Asteroid mining as a lifeline for space habitats. The key to long-term space colonization is not just getting people to another world but enabling them to thrive there. That means providing water, fuel, building materials, and other essential supplies, all of which are available in asteroids. Unlike Earth or other planets, where resources are often buried deep underground or locked away in complex ecosystems, asteroids offer materials that are more accessible. Water, in the form of ice, can be found on many asteroids, and metals like iron, nickel, and even precious elements like platinum are abundant on others. One of the most immediate uses of asteroid resources would be the extraction of water. Water is critical for life support systems. It can be used for drinking, growing food, and generating oxygen through electrolysis. More importantly, water can be split into hydrogen and oxygen to create rocket fuel, allowing spacecraft to refuel in space rather than relying on costly launches from Earth. This concept of in-situ resource utilization (ISRU) is at the heart of NASA's plans for future missions to Mars and beyond, where mining water from asteroids could dramatically reduce the cost of interplanetary travel. Imagine a scenario where a spacecraft traveling to Mars or another distant destination stops at an asteroid along the way to refuel. This would significantly reduce the need to carry large quantities of fuel at launch, lowering the cost and making long-term space travel more viable. Asteroids could also serve as way stations, offering fuel, water, and even materials to repair or build spacecraft during their journeys. In this sense, asteroids could act as the gas stations of the solar system, supporting exploration and colonization efforts. Building in space. Infrastructure from asteroid materials. Another critical aspect of space colonization is the construction of habitats and infrastructure. Sending enough building materials from Earth to create sustainable space habitats would be prohibitively expensive, but asteroid mining provides a solution. Many asteroids are rich in metals like iron and nickel, which could be used to construct buildings, space stations, or even entire colonies. With advances in 3D printing and manufacturing technologies, it may soon be possible to use asteroid-derived metals to fabricate structures in space. Instead of launching prefabricated parts from Earth, a colony could use raw materials mined from nearby asteroids to build everything from support beams to entire habitats. This would drastically reduce the cost of construction and allow for the rapid expansion of space settlements as more materials become available. The use of asteroid materials doesn't stop at basic construction. Future colonies may rely on these resources to create complex technologies, from energy storage systems to advanced communication networks. Metals like platinum and cobalt, found in many asteroids, are essential for high-tech electronics, batteries, and other components that will be needed to keep space colonies running smoothly. Beyond metals, Asteroids may also provide the raw materials for creating new types of building materials. Carbon-rich asteroids, for example, could supply the organic molecules needed to develop lightweight, durable materials for space habitats. The ability to manufacture advanced materials in space, using resources harvested from asteroids, could open up new possibilities for the design and architecture of space colonies. Sustainability and the ethics of using space resources. While the technical benefits of asteroid mining are clear, the ethical and environmental considerations of using space resources must also be addressed. As humanity moves toward establishing a presence beyond Earth, it's crucial that we do so in a way that minimizes harm to the solar system and respects the shared nature of space. One of the most pressing concerns is the potential for space debris. Mining operations could leave behind debris or disrupt asteroid orbits in ways that pose risks to other spacecraft or future missions. Ensuring that asteroid mining is conducted responsibly, with careful attention to minimizing environmental impact, will be essential to the long-term success of space colonization. There's also the question of whether mining asteroids for human benefit is ethical. Some argue that space, like Earth, should be treated with respect and not merely exploited for its resources. Others contend that asteroid mining represents a sustainable alternative to Earth-based mining, which is often far more destructive. In the end, the ethical debate may hinge on finding a balance between responsible resource extraction and preserving the integrity of the solar system. Asteroids as stepping stones to the stars. Asteroid mining is not just about extracting resources. It's about enabling humanity to expand its presence in the cosmos. By providing the materials needed to sustain life in space, asteroids could be the stepping stones that allow humans to travel beyond the Moon and Mars, to the outer planets, and eventually to other star systems. As we look to the future, it's easy to imagine a solar system dotted with human settlements, each one supported by asteroid mining operations that supply the essential materials for life and exploration. These outposts could serve as hubs for scientific research, commercial ventures, and even tourism, creating a thriving space economy that extends far beyond Earth. In this vision of the future, asteroid mining is not just a technological achievement. It's the foundation of a new era in human history, one where the resources of the cosmos are harnessed to create a sustainable, interplanetary civilization. By using the raw materials found in asteroids, humanity can build the infrastructure needed to survive and thrive in space, paving the way for a future where Earth is no longer our only home. Conclusion: asteroid mining as the key to human expansion. Asteroid mining holds the potential to unlock the resources necessary for space colonization, providing water, fuel, metals, and other materials that will make it possible for humans to live and work beyond Earth. As we move closer to realizing the dream of space colonies, the role of asteroid mining will become even more critical, enabling us to build, sustain, and expand our presence in the solar system. But asteroid mining is more than just a tool for survival. It's a stepping stone to a future where humanity is no longer confined to a single planet. By tapping into the resources of asteroids, we can create a sustainable, interplanetary civilization that reaches farther than we ever thought possible. Chapter 9: Technological and Financial Challenges Ahead. The idea of mining asteroids for valuable resources, while captivating, is fraught with immense technological and financial challenges. It's easy to get swept up in the excitement of a space-based economy where mining operations are in full swing and human colonies thrive beyond Earth. But the reality of turning this vision into a functioning industry is incredibly complex. Every step of the process, from identifying suitable asteroids to safely transporting materials back to Earth or using them in space, presents hurdles that must be overcome. And behind these technological challenges lies the equally daunting question of financial sustainability. Who will fund these operations, and how can they turn a profit in an industry with such high risks? In this chapter, we delve into the key technological and financial challenges that must be addressed to make asteroid mining a viable industry. From developing the necessary tools and spacecraft to convincing investors that the high-risk, high-reward venture is worth pursuing, the road ahead is anything but straightforward. The technological hurdles of mining in space. Mining an asteroid is nothing like mining on Earth. Terrestrial mining has the benefit of gravity, reliable transport networks, and decades of established practices. Asteroid mining, on the other hand, occurs in the harshest of environments: vacuum, microgravity, extreme temperature fluctuations, and radiation are just a few of the challenges. Crafting the technologies to operate in these conditions is one of the most significant hurdles the industry faces. The first step in any mining operation is finding a suitable target, and in the context of asteroid mining, this means locating asteroids that are not only rich in resources but also accessible. Many asteroids travel in orbits far from Earth or at speeds that would make missions prohibitively expensive. Technology must be developed to identify asteroids that are close enough to Earth's orbit, contain valuable materials, and are composed in a way that makes them mineable. Remote sensing, advanced telescopes, and AI-powered data analysis will all play critical roles in identifying the best targets. Once an asteroid is identified, reaching it becomes the next challenge. Spacecraft must be capable of long-duration missions, often lasting years, and able to withstand the harsh conditions of space. While reusable rockets and other propulsion technologies, like ion thrusters or solar sails, have made significant strides, the ability to reach an asteroid, conduct mining operations, and return to Earth remains a technical feat that requires ongoing innovation. Spacecraft designed for mining will need to carry mining equipment, fuel, and robotics capable of performing highly precise tasks, all while conserving energy and maintaining functionality over extended periods. Mining in space also brings a unique set of physical challenges. Unlike on Earth, where gravity helps to stabilize mining equipment and control the extraction of materials, the near weightlessness of space means that mining techniques must be completely rethought. Tools must be lightweight yet durable, capable of anchoring to the asteroid's surface while gently breaking it apart without sending debris flying off into space. Autonomous robots or drones, which can be controlled from Earth or operate independently, will likely be central to these operations, but their design must account for the fact that there is little to no gravity to assist them. Once the materials are extracted, they must be transported back to Earth, or perhaps to space-based stations or colonies where they can be used directly. This transport process is another massive technical hurdle. Moving valuable metals or water across the vast distances of space requires propulsion technologies that are not only efficient but also capable of safely protecting the cargo. The development of space elevators, tethers, or orbital processing stations has been discussed as potential solutions, but these are still in the conceptual phase and years from being realized. Financial viability, the high costs and risks. Even if the technological barriers can be overcome, there's another, perhaps more daunting challenge: making asteroid mining financially viable. The cost of getting into space is extraordinarily high. Rocket launches alone are still expensive, despite recent advances in reusable rockets. Beyond the cost of launch, mining operations require specialized spacecraft, robotics, processing equipment, and infrastructure that must be developed, built, and tested. All of this requires massive upfront investment, and there is no guarantee of immediate returns. Private companies venturing into asteroid mining need to convince investors that the potential rewards outweigh the risks. For most, this means raising capital from venture capitalists, governments, or large corporations willing to take a long-term view. But the timeline for profitability in asteroid mining could be decades. Unlike industries on Earth, where returns on investment are expected in a few years, space mining companies must sell investors on a much longer horizon, one that is filled with uncertainty. The high level of financial risk is compounded by the unpredictability of the market. Asteroids contain valuable materials like platinum, gold, and rare earth metals, but flooding the market with these resources could drive prices down, undermining the very profitability of the enterprise. If the supply of these metals suddenly increases, traditional mining companies may see profits fall, leading to a broader market adjustment. Space mining ventures need to carefully consider how they will manage this influx of materials to ensure it doesn't backfire financially. Governments may play a crucial role in helping to offset some of the financial risks. National space agencies or international organizations could provide initial funding for asteroid mining projects, much like they have done for scientific space missions. Public-private partnerships may also emerge, where governments assist with infrastructure costs while private companies handle the operational aspects. This type of collaboration could ease the financial burden on companies while ensuring that space resources are exploited for the benefit of all. Another financial challenge lies in developing a sustainable business model. While extracting resources like platinum and gold offers clear financial incentives, other materials, such as water, may be more valuable in space than on Earth. For example, water mined from asteroids could be used to create rocket fuel in space or provide drinking water for space stations. This means that asteroid mining companies could generate revenue by selling resources to other space ventures, such as those involved in tourism, scientific research, or space colonization. However, developing this ecosystem of customers and ensuring that there is enough demand to justify the high costs of space mining will take time. Overcoming investor hesitation, building confidence in the industry. Asteroid mining is often referred to as the next gold rush, but investors remain cautious. The industry is still in its infancy, and no large-scale commercial mining operations have yet been completed. Investors are looking for proof that the technology works and that the resources are as valuable as promised. Without this proof, asteroid mining remains a speculative venture. To overcome this hesitation, space mining companies must demonstrate tangible progress. This could include small-scale missions to retrieve samples from asteroids or demonstrate the technology needed for mining operations. NASA's Osiris-RX mission, which successfully brought samples from the asteroid Bennu back to Earth, is a significant milestone that helps build confidence in the feasibility of space mining. As more missions prove that it's possible to reach asteroids, extract resources, and return them safely, investor confidence will likely grow. Additionally, companies may need to diversify their revenue streams while they wait for asteroid mining to mature. For example, space companies involved in launching satellites, conducting space tourism, or partnering with governments on space exploration could use these ventures to fund their longer-term mining goals. By demonstrating profitability in related areas, they can show investors that they have a viable business model while working toward the more speculative goal of asteroid mining. The road ahead, a long-term vision. Asteroid mining is not an industry that will emerge overnight. It's a long-term vision that requires significant investment, technological innovation, and patience. The companies and nations that succeed in this field will need to have both the resources and the determination to overcome the myriad challenges ahead. Despite these obstacles, the potential rewards are enormous. Asteroids contain materials that are critical to many industries on Earth, from electronics to clean energy. More importantly, they offer the raw materials needed to support human life in space. As humanity pushes further into the solar system, asteroid mining could provide the resources to sustain space colonies, build new technologies, and fuel a thriving space economy. In the end, the challenge of asteroid mining is about more than just solving technical problems or securing funding. It's about laying the foundation for a future where humanity can expand beyond Earth and create a sustainable presence in space. The companies and countries that invest in asteroid mining today are not just seeking profits. They are pioneers in a bold new era of exploration and industry. Conclusion: turning challenges into opportunities. The technological and financial challenges facing asteroid mining are significant, but they are not insurmountable. With the right investments in research, development, and international cooperation, these hurdles can be overcome. Asteroid mining has the potential to become one of the most transformative industries of the 21st century, offering new opportunities for economic growth, technological advancement, and human expansion into space. As we look to the future, it's clear that those who succeed in asteroid mining will not only unlock the vast wealth of space but also pave the way for humanity's next great adventure, living and thriving beyond the bounds of Earth. Chapter 10: Asteroid Mining and the Space Economy. What's next? As we stand on the brink of the asteroid mining revolution, it's clear that this emerging industry is not just about extracting metals and water from space. The implications of asteroid mining stretch far beyond individual companies or nations seeking profit from celestial resources. What's unfolding is the birth of a new kind of economy, one that extends beyond the boundaries of Earth and into the vast, resource-rich expanse of space. Asteroid mining is set to play a pivotal role in shaping the future of this space economy, but its influence will ripple through industries and societies in ways we are only beginning to understand. This final chapter will explore how asteroid mining could drive the evolution of the space economy, the industries it will likely transform, and what role it might play in humanity's broader push into space exploration and settlement. More than just a commercial venture, asteroid mining could redefine how we live, work, and thrive in the cosmos. The catalyst for a new space economy. Asteroid mining has the potential to be the cornerstone of a new economy that operates primarily in space. Until recently, the economic activity related to space was largely confined to satellite technology, communications, and government-funded exploration missions. The advent of private spaceflight companies such as SpaceX and Blue Origin has started to change this dynamic by lowering the cost of access to space. However, the full realization of a space economy, one that includes industries like tourism, construction, and even manufacturing, will require a steady and reliable supply of resources. This is where asteroid mining becomes essential. The materials locked within asteroids are not just valuable in economic terms, they are critical for enabling sustained human activity in space. Metals like iron, nickel, and platinum are needed to build spacecraft, space stations, and the infrastructure required for long-term habitation. Water, which can be split into hydrogen and oxygen, is the key to creating rocket fuel, allowing for interplanetary travel without the need to constantly launch fuel from Earth. In short, asteroid mining offers the resources that will fuel the growth of a space-based economy. But beyond the direct supply of materials, asteroid mining could serve as the foundation for a whole new set of industries. Imagine space stations that serve as processing hubs, where raw asteroid materials are refined and used to build everything from satellites to habitats. Factories in orbit could take advantage of microgravity environments to produce advanced materials or conduct research that is impossible on Earth. As these industries develop, they will create jobs and economic opportunities not just for spacefarers, but for those on Earth who support these operations. Transforming industries on Earth. The impact of asteroid mining won't be limited to space. The materials harvested from asteroids, precious metals, rare earth elements, water, could significantly disrupt industries on Earth. Currently, many of these materials are difficult to extract and refine on our planet, leading to environmental degradation and high costs. By sourcing these materials from space, asteroid mining could relieve some of the pressure on Earth's natural resources, reducing the need for environmentally destructive mining practices. Take platinum, for example. This rare metal is crucial for many industries, from electronics to renewable energy technologies like fuel cells. If asteroid mining brings a new abundance of platinum to Earth, the cost of these technologies could drop significantly, accelerating the shift toward cleaner, more sustainable energy sources. Similarly, rare earth elements, used in everything from smartphones to wind turbines, are currently difficult and costly to mine on Earth. A reliable supply from asteroids could make advanced electronics and green technology more affordable and widely available. On the flip side, industries that rely on terrestrial mining might face a significant downturn if asteroid mining becomes a reliable source of these materials. Traditional mining companies may need to adapt or shift focus to stay competitive in a world where space resources are becoming part of the supply chain. This shift could lead to a realignment of global markets, as spacefaring nations and companies become dominant players in the resource extraction industry. Space colonization and sustainability. One of the most profound impacts of asteroid mining will be its role in supporting human life beyond Earth. For many advocates of space exploration, the ultimate goal is not just to send probes or astronauts to other planets, it's to establish permanent human settlements in space. Whether it's on the Moon, Mars, or in space stations, these colonies will require vast amounts of resources to sustain themselves. Asteroid mining provides a viable solution to this challenge by offering a source of essential materials directly in space, reducing the need for costly and unsustainable supply missions from Earth. Asteroids could become the lifeblood of space colonies, providing water for drinking and growing food, metals for construction, and fuel for spacecraft. The ability to extract these resources in space, rather than transporting them from Earth, makes long-term habitation in space far more feasible. Moreover, this model of using local resources to support human life could extend to other planets, like Mars, where water, ice, and other materials can be mined and utilized to build colonies. Sustainability is a key theme in discussions of space colonization, and asteroid mining aligns with this goal. By relying on resources found in space, we reduce the environmental toll on Earth and create a self-sustaining ecosystem that could one day support millions of people living and working in space. In this sense, asteroid mining is not just an industry, it's a pathway to ensuring that humanity can expand beyond Earth without exhausting our home planet's resources. The long-term vision, a multiplanetary economy. Asteroid mining represents the first step toward a future where humanity operates a multiplanetary economy. In this vision, Earth is no longer the sole center of human activity. Instead, our economy stretches across the solar system with different planets, moons, and space stations serving as hubs of production, research, and commerce. Asteroid mining provides the raw materials that will fuel this expansion, enabling humans to build and maintain the infrastructure needed to support life beyond Earth. In this multiplanetary economy, asteroids may serve as key trading posts or resource depots, where spacecraft stop to refuel or resupply on their journeys between planets. The extraction of materials from asteroids could also lead to new trade routes, where resources are shipped between space colonies or sent back to Earth. Eventually, we may see a thriving network of space-based industries, from mining and manufacturing to tourism and research, all interconnected by the flow of resources from asteroids. Of course, this vision is still decades, if not centuries, away. But asteroid mining is the first tangible step in this direction. By unlocking the wealth of resources found in space, we lay the groundwork for a future where humans can not only survive but thrive across the solar system. Conclusion: the dawn of a new era in space. As we stand on the threshold of asteroid mining and the dawn of a new space economy, it is clear that this moment marks one of the most transformative periods in human history. What was once the realm of science fiction, mining precious metals and water from space, building human colonies on asteroids, and creating an economy that spans the solar system, is now within our grasp. The incredible technological advancements, coupled with the visionary determination of both private companies and nations, are bringing this reality closer each day. Asteroid mining, while still in its infancy, holds the potential to fundamentally reshape life on Earth and beyond. The resources contained in asteroids are more than just a solution to the depletion of Earth's finite materials. They represent the key to sustaining life in space, fueling interplanetary travel, and building the infrastructure necessary for human expansion throughout the cosmos. These celestial bodies, orbiting quietly in the vastness of space, are the stepping stones to a multiplanetary future. However, this journey is not without its challenges. The technological, financial, legal, and ethical hurdles that lie ahead are significant. Yet these obstacles are not insurmountable. With continued innovation and collaboration, humanity is poised to unlock the vast potential of the solar system. The pursuit of asteroid mining is not just about profit or resources. It's about ensuring the survival and growth of humanity in a sustainable, responsible way. As we venture into this new frontier, we must remember that space is a shared resource, one that belongs not to any one nation or corporation but to all of humanity. The decisions we make now will shape the future of space exploration for generations to come. Whether through the development of new technologies, the creation of international laws and treaties, or the establishment of ethical guidelines, it is up to us to ensure that space remains a domain of opportunity and discovery for all. The gold rush of the future is not about greed or exploitation. It's about a deeper understanding of our place in the universe, about unlocking the resources that will allow us to explore, innovate, and expand beyond the limits of our planet. Asteroid mining is the first step in a journey that will take humanity to the stars and beyond. As we look toward this bold new future, the possibilities are endless. Whether you're a scientist, an investor, a space enthusiast, or simply curious about the future, asteroid mining represents an extraordinary leap forward. This is not just a story of technology or economics, it's a story of human ambition, vision, and the unyielding drive to explore the unknown. The future is out there waiting for us to discover it. The question is, are we ready to take the leap? The answer, as history has shown time and again, is a resounding yes. We are standing at the dawn of a new era, an era in which space is not just a frontier to explore but a home to build. Asteroid mining will be the key to unlocking that future. And the gold rush of the stars is only just beginning.